In this video, I am going to explain how to write Verilog code for 1 to 2 Dmux using structural level of abstraction. Before going into the code directly, let me explain the working of 1 to 2 Dmux. So the input will be one input for 1 to 2 Dmux and you will have two output terminals. Depending on the select input that you are giving, if your select input is 0, then this path will be activated, and if your select input is 1, then this path will be activated. So you can write here, if you are considering this as out of 0 and out of 1, or O of 0 and O of 1, then you will get here, if select input is 0, that means S bar into I, and here S into I. So these are the two functionalities that you have to write to get a 1 to 2 Dmux. Okay, now let's see how to write the code. Clearly you can see here I have declared my output as an array 1 down to 0, and my input will be a select input of single bit because 1 to 2 Dmux and input I. Now if you see here, I am assigning O of 0 is S bar and I, and O of 1 as S and I, like as I stated here. So that's it. With that you can simulate or synthesize a demultiplexer in structural level of abstraction. Let's see how to write a test bench also. I'm not going to simulate, you can do on your own because I have changed the name, so I have to write the test bench again. For that name, you can see here I have changed it as de-mux underscore structural, but before I have written as ternary. So the idea of Testbench is to test all the possible combinations that are possible. So initially I am initializing my S as 0, that is select input as 0. For every 2 time units I am incrementing it by 1, so it will become S equal to 0 1 0 1 like that, because since it is single bit, the carry that is generated will be omitted. So I am stopping the simulation after 10 time units. You can try this on your own and you can check the RTL schematic and timing waveforms, which will satisfy for sure. Thank you for watching. That's all for this video. See you in the next one.